Congratulations, guys. You're on college camera.
Just week one.
Okay.
Yep. Oh, I guess. I don't know. You're looking at it, not me.
You good? Have a good evening. Okay. Technological malfunctions are finally solved for now.
One toolbox short, everybody can have one.
We still got one more fill?
We haven't got any filled, but I lost 2 students, actually I lost 3, one dropped in my afternoons, and then 2 that iPhones dropped, or disappeared, never came to class. Cause I share with these 2, we've got 4, right? I think we've got 4, not 5. This Cameron needs 1, which would be 5 people.
That's if Cameron hasn't already got his stuff transferred.
No, Cameron's in my classes.
Oh. Wow. I don't know.
I was
The
saying-
last I heard was 7 on Monday
Yeah, but
that we
lost
still needed.
3, I think, since then.
So yeah, then we only need 4.
We're getting closer. We still need 5, cause you got Cameron too, he doesn't have one. Oh,
But
I
yeah,
have, no,
yeah,
it's
but you
6.
said he's in one of your classes, so.
Well, no, but he doesn't have one. He's in my night class also. I've got 2 that aren't in this room to add to yours. So that'd actually be 6. I forgot another one. Because Cameron wasn't here last night, but the one for my deal was.
Cool.
So yeah, we're still too short, unfortunately. That won't be much longer, guys.
So hopefully we'll still be able to
You got my number
start
on your
our
phone?
projects. Has it changed since 111 or whatever it was?
Maybe. I text.
I've got you on Facebook anyway.
Send me a message if you need something.
Alrighty. Okay. Yes, yes it is. Oh, I meant to ask him about a remote, if I can use it to just click through the pages. Oh well, I'll click through the pages this way. All right, I guess since we're recording now, we'll get going through this. Everybody's got NIM set up now, right? You've already got one quiz done. Sneaky. And which one was that? Safety?
General safety knowledge quiz.
Before we even go any further, I never went through this the other day. I know you're Jack, but I don't remember any of your names. Chris, Josh, and Matt. Okay. You guys remember mine? John. I don't know if
Jack is the nickname for John.
I didn't know that. It's news to me.
Like John Kennedy, Jack Kennedy.
I've never heard him called Jack Kennedy.
Learn something.
Something new every day. Okay, so some of this stuff I've never even seen before, but we are going to go through definitions of machining and machine tools, how we're going to treat our machines in daily life, what our major machine tools are, and history of machining, which that might be interesting. So, definition of machining is using machine tools to cut materials to desired sizes and shapes. And a machine tool is obviously the machine-operated tool you're using to make those cuts. Let's see. So we've used machine tools for centuries, apparently. Earliest were hand-powered, and later they were powered by animals or water. progressed to steam power, and most recent machine tools are obviously electric. I hope that some of your quiz answers are in these. I really do. So that's pretty fancy. The Great Wheel Lathe. Power machine tools. So the bow drill and the pump drill. And my father-in-law actually has one of these. I tried to use it, it went horrible. As a matter of fact, I'm pretty sure I broke it. It was already really close to breaking anyway. Just a little wore out. There we got a water-powered boring machine. That's fancy. You know, I always kind of wondered how they made cannons back in the day. I guess that would have been it. Well, cast too, but right there. First used to machine cannon bores and then cylinders for steam engines. That's pretty cool. See, I'm going to learn some new stuff with you guys today, apparently. Fancy little old school milling machine. And then we've actually got a 5-axis out in the shop now. If you guys haven't seen it, it's dovetail mounted and everything. It's the UMC 750, I think is what it is. Great big full 5-axis machine. That's gonna be really cool to see run and learn how to run.
I'll learn how to use the ones that subtract material.
That would be pretty cool. Okay, so our role in society. Oh, let's see. So society obviously uses manufactured items every day, and the machining industry produces end products and components. Machining produces shapes and sizes with great precision. I would say that depends a lot on the operator. I've seen some stuff that was supposed to be an inch that was definitely a lot less. Somebody's too used to compensating. I probably shouldn't say stuff like that. Machining shock absorber components and an assembled shock absorber. Huh? Somebody's. Okay, so in figure 1.1.6, machining shock absorber components and an assembled shock absorber used in motorsports racing. And in 1.1.7, machining produces medical products such as hip implants and surgical tools. Wrong mouse. I'm going to get used to this one of these days. Okay, so this one I kind of want you guys to pay a little bit of attention to, because locally, this mold right here is more what you'll get into working at the local factories. Now at Stanley, not so much molds, but we'll do blanking dies. So rather than a big concave mold like that, you'll have through holes that are all EDM'd in place to hold tolerance. Maxian though, you'd be making a lot of molds. They've got to have way nicer machines than Stanley does too. How many of you guys are actually living local, gonna be working local. So pretty much everybody in here. Cool. We'll get more into what some of the places you can apply to are later, where you can actually get a machining position. But that's just obviously half of your mold for, I can't tell from that angle what that part is. But anyway, couple machined plastic components. I hope for y'all's sake you never have to machine a whole bunch of plastic. It is not, it moves around while you're cutting on it way too much. It's tough to get used to. There's a prime example of the kind of stuff that you would do at Stanley at least. That's a progression die, so you can see the start of it right here. And that is going to come off of a strip being fed by a coil into a press. And these holes here will be EDM'd into the dissections. And then your cut-off blades, most of the time you'll grind to size. But it stamps, feeds, stamps again, and as it progresses through 1, 2, 3, 4, 5, 6, 7 hits before it cuts off the part, it looks like, you finally wind up with that part. And I wouldn't want to work on that thing if they had it at Stanley. That looks like pretty thick material. If it gets double parted, things go boom. So, I guess I could have just read that, huh? This progressive die has 8 stages, apparently. I can't count. Each stage shapes the part further from a strip of material. At the final stage, the die cuts the finished part off the strip, and then, like I said, final product down there. The machine produced this mold that forms plastic food packaging. That's pretty fancy looking. That looks way smaller than what it actually is. Have we answered any quiz questions yet, at least?
I'm sure you have.
I'm really not a fan of PowerPoints, but you'll have to bear with me. First semester teaching, trying to get used to what we've got to go through, and then I'll adapt from there.
So we are guinea pigs.
Huh?
We are guinea pigs.
Pretty much.
I'm fine with that. Usually that means there's some leeway.
I'm a lot better at hands-on instruction, so once we get out to the shop more, that's where I'll be
It's
more
your time to shine.
comfortable. Yeah, I'm not a real tech savvy person, but I guess I'm gonna have to become a little more tech savvy and a little better at reading.
Delivery.
Yeah, PowerPoint delivery. There we go. A service we called this Death by PowerPoint. And man, I'm really trying to kill y'all with it today. Okay, basic types of machine tools. Conventional or manual machine tools require a human operator. And CNC tools are directed by computer controls. Obviously, they still require an operator most of the time. You guys will, those of you that are in CNC classes right now, will figure that out. There are ways that you can really automate big runs of parts. Let's see. So this is something that you're gonna be using, if not today, then definitely Monday, I would say. Little horizontal bandsaw we've got out in the shop. We'll get our stock cut up for our projects. And actually, maybe not, because we don't have toolboxes for you guys yet, and I believe that was the plan, is get 2 pieces of stock cut for each project and keep them in your box. So, yeah, I'll give you a little demo of how to run that, as well as our vertical bandsaw out there. Super dangerous if you don't watch what you're doing. FYI. And that is a circular blade type sawing machine. I'd explain it if I could, but I can't see exactly what's going on in that picture. And more what you'll run in your CNC classes. Or no, that is not a vertical mill. That is a CNC controlled saw. I forgot those existed. But they do. They're kind of cool though. They'll pull, you just set up say a 24-foot bar on them, tell it to cut X amount of pieces every 12 inches, and it clamps, cuts, pulls, clamps, cuts, pulls. You can actually get one for your home shop for $3,600 from Tormach. It's not CNC, but they've got a automatic feeder for it. Okay, drill press is going to be one of the very first machines that we use outside of the bandsaw. There's only going to be one hole in your T-slot cleaner, and that one's a lot of fun because that's really thin material. But we'll see how we do on that. My instructor, when I did the T-slot cleaner, had us, so we rough cut it on the bandsaw. Everything else we did by hand file. That was a very noisy project for a lot of people. And if you guys remember the old machine shop, that little room echoed like crazy. Okay, some cylindrical parts. That's all stuff that's been done on the lathe. Pretty similar to the lathes we've got out here. We've actually got a couple of live tool lathes out in our shop now. Best manual mill ever made, Bridgeport. Ours out here at Birmingham. I don't think Bridgeport actually runs anymore. Of course, another CNC mill with an automatic tool changer. So you can kind of see the difference there. That looks like a picture of stuff that we've actually done here. I almost want to say it is, but I'm not going to put money on it. The bench grinder, pedestal grinder, for those of you that have never messed with them, I think there's probably only one person in here that hasn't. Have you ever used one? Bench grinder? Man, all I can tell you is be careful. I mean, you can blow that wheel up if you put just a little too much pressure into it, and whatever material you've got that you're grinding on gets stuck between the guide and the wheel, That's a frag grenade going off in your face. Really? I still haven't seen one blow up. I have, however,
It was a circular grinder though. It wasn't like a big flywheel grinder.
trying to think what you're talking about. You're talking like so you're not talking angle grinder or bench grinder, but,
No, it's like a bench grinder, but instead of it being spinning this way.
oh, disc grinder.
Yeah.
How did they blow one of those up?
Piece of pipe went through it and got stuck and
Yeah, those are usually,
bearing shaft,
yikes.
and the flywheel went that way across the shop.
That would have been scary.
Yep.
The surface grinder is what this is called. You know what? I'll give you a little tour of that when we go out to the shop. We'll go through all of that stuff. A graphite electrode that acts as a cutting tool and a sinker EDM. You guys can YouTube that. It is super, super cool. So that will actually be mounted onto a tool holder in an EDM machine, and it'll cut out that shape by eroding the steel away. Kind of like unwelding.
You say EDM machine, you don't mean electronic dance music machine, right?
No,
Okay. Just had to clarify.
don't ever play that in here either.
Good to know.
I don't know, some of it's not bad. But there they are mounting the electrode on the EDM. So basically any material that conducts electricity, you can EDM, which is electrostatic discharge machining. You're literally burning the material away. So it says here, the work being machined by the EDM must be submerged in a liquid called dielectric fluid during operation. We've got wire EDMs at my shop. That dielectric fluid is deionized water for us. That's that's really good looking work for a water jet.
Water jets.
Oh no, never mind. It is EDM. So that's being on a PowerPoint. I thought we were going into something totally different, but no, that's all stuff that's done on an EDM. And most of them will be like you can see, kind of see in the picture here. They've got a head here and then another up here. Most of them can move totally independently of each other. So you can make a circle that is, say, an inch on the top, that's 3 inches tall, and then it'll be 3 inches wide at the bottom. Or all kinds of other angles or shapes. But you're splitting tenths, 10,000ths on an EDM machine. So the wire EDM uses a very small diameter electrically charged wire to cut through material. A flow of water helps wash away the eroded material. If I hadn't done a good job explaining that already. Hey, there we go. Now we're getting into lasers and water jets. Lasers are pretty cool. I like them. And that's what's going on here. Parts getting lasered, sheet metal. Uh-oh, not printing that. And water jet machine. Like a pressure washer on steroids. Okay, cool. No, PowerPoint number 1 down.
You ever seen someone get their finger cut off by a water jet?
No, but that is actually, you know what, let's get out of the classroom for a minute, I'm dying.
Quick question.
What's up?
How thick of material can a water jet cut through? 6, 8, 10, or 12 inches?
Depends on the water jet if you're using abrasive under the water.
I'm gonna say 12 inches.
I'm gonna say that's gonna be in a different PowerPoint or the book.
You can Google it.
Yeah, I don't know right off the top of my head, but.
I'm figuring that's a good question.
They can cut pretty thick shit.
Okay, so that'll be your first project. So what we'll do when we have tools and toolboxes for you guys and access to stock to cut and whatnot is make this guy. And I don't see a. Everybody see that all right still? Wrong in your way. Huh?
In my own head.
Looking at the tolerances?
Yeah.
They gonna be too tight for you?
No, those aren't bad. Compared to what we do with work, it's not bad.
Okay. I'm trying to get to where I can see and not, you know what, I'm just gonna stay. I don't,
That's a good
no
idea.
matter where I go, I'm blinding somebody.
You're actually fine right back there.
Huh?
You were fine right there by the toolbox.
Yeah, but then I can't see the screen to explain anything to you. And you can find this yourselves too, if you go to your modules in Canvas, and then under module 1, it's all the way at the bottom. So our tolerances on this guy, that won't let me highlight, dang it, are gonna be for 2 place decimals, plus or minus 20 thousandths, and plus or minus 10 thousandths for 3 place decimals. Everybody pretty well know what that means. What'd you say your name is again? Matt, Josh, and Chris. Okay. So we're talking what? That says we're 560 thousandths from this edge to the center of that hole and from this tip to the center of that hole. So if we're on the high end of that tolerance, what will our location be on that hole? If we're at the high end of our tolerance on, let's just say we moved that hole this way. To the top end of that tolerance. And what'd you say, Chris?
0.55, 0.57.
Yep, that'd be your tolerance range.
Oh, no, it could be more than that because I was looking at 3 place decimal.
Oh, yeah.
So then, yeah, 4 to 8, right?
Yep, 540 thou to 580 thou. So, I mean, you've really got a mile on that hole. That's why we're doing it on the drill press. Got nothing on angles, so I'd say get that as close as you can. That's a good general rule on everything you are ever gonna do in machining. Get it as close as you can. Then you don't have to worry about it. So you guys that have been through welding, I know you're gonna be pretty good in layout, I would assume.
I would hope so.
No. Have you done any kind of layout for any of your classes? What about you, Matt? At CNC, you probably won't do much layout at all. So that's all right. We'll go through once we get some stock cut. I'll show you a couple different ways you can lay some of this stuff out on a piece of stock before you get started cutting. I don't really see anything on here that's going to matter whether you do one thing before the other. Other than maybe where and what direction you start roughing that out on the bandsaw. You can either make it real easy on yourself or make it real hard. Or nothing about it's going to be real hard. On all of our prints here, you'll have a stock size at the bottom. That's what you'll saw cut it to. Is the way Justin draws them up. Your stock size is what you're going to cut it to on the bandsaw. And that leaves you plenty of room to rough stuff out. Now, I will say, yeah, that's what you'll start with. Now, I would say, if you think there's a solid chance you're going to mess that up, instead of 2 inches, go ahead and cut it 2.5 on that one. Excuse me. But we'll see when we get there. Anybody got any questions on that at all? I really wish we could get toolboxes inventoried and checked out and all that stuff. It'd be really nice. And let's see. So, Chris, did you do the general safety or safety for machining?
General safety. And I had a question about that safety machining. I don't know. I think that we have to go to that. What's it called? Immerse to learn. See where it's at. We have to.
I could have swore Justin said that we were done with Immerse to Learn. But I may have misunderstood him. He may have meant next semester or.
There's a link there.
Let's just see. No, really, let's just see. It's been a while. Yep, that's what I figured. No, don't do that. Don't mind me, I'm just gonna lock myself out of it real quick. I'm gonna go with, I'm gonna have to get logged back into there one way or another at some point. So I'll get back with you on that, if we don't see Ed again today. His laptop's already gone, so I'm gonna say we won't see Ed again today. Hey, you know what? There is one thing I just thought about that I don't remember hearing in the syllabus about tests. Okay. Do you guys remember Justin going over the grade scale the other day? Or not the grade scale, but the weight of your projects, tests, and whatnot?
Yeah, part of it. Yeah, I remember he said the certification was 20%,
Yeah. Yeah, that's all I remember in science.
projects are half.
Okay, so that's why when I thought about it, I wanted to go ahead and touch base on it, because our shop projects are gonna make up half of your grade. So, but like Justin said, on the certifications, you can refuse them, but you'd be kind of crazy to. I mean, just in my shop that really rarely ever hires, we've hired 3 people in the last 2 years just based on their certificate and NIMS certs that they had. And I got a bunch of raises out of them. As I went through school. And so I would say absolutely do the certifications. So that's your projects and your certs are gonna be your first 70%. The last 30% is gonna be your classwork, homework, and anything else. I mean, literally, Justin used to, like when we were going through the whole COVID thing and had the option to come to class or stay home, he would give us like 10 bonus points to show up to class. Or if you can tell me, like he would tell us something in class and then make a quiz about it in one of our modules and say, if you show up for class, there's bonus points in this quiz for you. I don't know if we're still going to do anything like that or not, just for the simple fact that it's supposed to be a flexible semester or flexible course as far as your time goes. He did go over what times the shop's open throughout the day, right?
Pretty much. I mean,
From-
Ben just said it was like all day.
Yeah, like
As long as you
8 to
let
8
someone
basically,
know.
Monday through Friday.
The major points I pulled out that was open every day, as long as you let someone know you're gonna be in there.
Yep. Pretty much the same way over here. Okay. Sorry, I got sidetracked, but I wanted to make sure that just in case any of you cared about that, we went over it. I know we touched on the rest of it the other day. Silence it. Silence it.
That's the whole point of my school over there.
Huh?
That's the whole point of having my school mem set up on this thing, but still.
Oh,
Well, that focus was on
That's another good thing to do. If you guys haven't already set up alerts from the campus, I would do that sometime before we start getting snow days. Cause,
Yeah, where you go to do that?
Oh, yeah, we might.
I will show you.
Email and phone.
I'm gonna show up if no one's here. Fuck it.
And I've done it.
Yeah.
And I had alerts set up. So I'm preaching this to you about setting up alerts so that you don't drive all the way out here for nothing.
I live across the street.
Well, it's not all about you.
In my world it is.
Touche. Why is my brain doing this to me?
I don't know about you, but I always have my own world.
Me too.
Yeah.
What'd you say, Matt? You say something? Josh, you say something? Somebody say something? Anybody other than Jack say something?
I did, yeah.
Jack off.
What'd you say?
Find that out. Yeah.
I was telling Josh, I already know, I always know when the
Yeah.
school's closed, my wife works out here.
Oh. Lucky.
Yeah.
Right. Perfect. I think I send out emails anyway.
Okay, so when you go to your SFCC homepage, it's right here. It literally is a link that says alert.
Seems
Yeah, I
like
think I did
sometimes
do
I get
that.
them and sometimes I don't.
Huh?
Seems like sometimes I get them and sometimes I don't.
Yeah, that's what happened to me. Like, seems like half the time they'll work.
Or they'll come.
Shit, you get them for the tornado siren test all the time.
Yeah.
I just wanted to make sure that this was actually. Yeah. Campus closures. That's a good point too, though. If you're ever questioning it, you can come over or come to this webpage, go to the alert, then hit campus closures, and it'll tell you right then and there whether you have to show up today or not. And then I guess it'd be if I could remember how to set it up, that would be awesome. Okay, right there, go to my SFCC. Up to 3 mobile phone numbers and 3 email addresses can receive SFCC alerts. Yeah. I hear you talking about me.
Yeah.
So he went down here and looking why he was doing it.
All right, I'm gonna make a deal with those of you that are worried about this. You know how to get to it. If you figure out how to set it up, cool. If not, let me know. I will mess with it when my info ain't blasted up there and refresh my memory on how to do it and walk you through it. Now, I'm gonna flip through this real quick because like I said, I don't like PowerPoints if there's stuff that I think, I mean, these are really great for you guys to have in Canvas for references, for your quizzes and all that.
That lesson didn't have the question or the answers to the questions you're gonna have to go through the book. 'Cause I remembered some of them from scanning through the book earlier. But I was wrong on that water cutter, 12 inches is too deep, 6 inches.
I thought it might have been. I didn't even think it would cut 6 inches, honestly. But we've gotten dye shoes in when we rebuilt dyes, that it, you got all the cutouts for your slug relief in the bottom of it for it to drop slugs that are stamped out. Normally, you see like weld marks or laser burns on it where it's been cut out with a plasma torch. We had one recently show up where it was just a little bit of rust right around the rim of it. We're like, what's going on there? That's weird. There's no way a water jet cuts through 2.5 inches of steel, right? Apparently there is. Huh?
Using garnet at that point.
I have no idea. But if they're using garnet, I'm gonna need to filter that water.
Yeah.
What are we looking at here? What did I do? I skipped way too far ahead, that's what I did. Okay, we're going through specialized machining jobs. Okay, modern machining careers, both physical and mental skills, but are safer than in the past. Skilled machinists are in demand. Okay, safer than in the past. That completely depends on you. 100%. I mean, I just told you my grinder story. And I mean, it's not like they all have, I'm sure some of them do, but it's not like they've got sensors to tell them, hey, there's some idiot's head in there and they're trying to push go. Most of them are just going to go, whether your head's in the way or not. So,
I've seen them, they put a hot dog up there and it
Breaks the blade.
Yeah.
Yeah.
and it did what?
It shatters the blade, so if it's,
It's
like,
got
it
like-
cuts the, hot dog touches it.
Yeah, it has a brake that clamps on the blade and just stops it instantly.
Yeah. I'm sure someone will make a better idiot to break that. I don't know.
I'm not sure I even want to get into this. I mean, this could go to some dark places.
I mean, if you don't know.
That's fine.
I
I'll laugh.
I just wanna know who found that out the hard way.
I'm just going to try to get into the habit of filtering what goes on in here from coming out of here. Oh, let's see. Okay. Yes, you will definitely need to be able to read prints. How many of you guys have worked with blueprints before? A little? Well, I'll have to look at my book and I won't be able to project it. But there, I forgot I put it over here instead of over there. Oh, I don't know if you guys have the habit of throwing all your notes and books away or returning your books at the end of every class. This was the book I started manual machining with like 3 years ago, and we're still using it now. Definitely don't return that book. And I kept mine simply because there's a lot of really good info in there aside from the machining principles and stuff, different trig formulas and calculations and stuff like that that will really help you. Ha ha ha. So are you actually getting a degree or certificate in welding or machining?
I already have a degree in welding. I took it more as a refresher course for when I was looking for a job.
Gotcha. So what are you what are you doing in machining?
Um,
What's your end game, I guess? Not like a, hey, you can't handle this.
Try to get basic skills of it and then maybe go further into it.
It is a crazy, crazy world.
From what I can see so far, yes.
I love it. I was a jet engine mechanic for 6 years, and I like this more.
Really?
I mean, I opened up jet engines and seen the turbine blades and cases in there and everything else, and I'm going, how did they make this crap? And now I know.
It's like everywhere I go, where like I see welds, I'm like, that dude doesn't know he's doing
And that's one thing
it.
that,
It's so annoying.
well, you'll see it with machining too. You'll start to realize just by grabbing a hold of one of your tools or something you just picked up from Walmart, you'll look at it and go, how did they make this? Oh, man. Oh. They did a crappy job covering that up, or they didn't deburr that well enough.
Yep.
Or there was a slug in the die. Sometimes it's annoying, the stuff that you start to see as you get into this. Like, man, where did people's pride go?
You know how much dizziness it sucked going back to after learning how to weld? Like, no joke. It's fucking horrible.
Oh, I'd imagine.
Yeah. I have a buddy who works in now, and he's like, man, half the shit we do here wouldn't fly anywhere else.
No. No, and I won't even,
Yeah.
I'm not even going, I will not shut up for 3 days. So I'm actually looking for
Does it have, like,
a
diagrams in
section
there
of-
blueprints to like you can kind of learn off of?
Yes, that's exactly what I'm looking for, is there's a, there's a section in here that touches on a lot of what you're gonna need to know for print rating, or prints, 21, man. I think I'd have been better off just flipping through the first few pages of the book at that point. It took me way too long to find what I was looking for in the index, but that's new to me. I'm not used to that. See, if I had a projector up here like Justin's got in his classroom, I could blast my book up there until you guys get yours in. Which actually, this right here may be straight out of the book.
It's actually not a bad.
Looks like it is.
It's just got a lot of shit.
Both of them are.
And I think it is. I think you'd be right.
Our actual first project was nice.
Hmm.
The print quality that I'm comparing from work to here is astounding.
Yeah, in the real world, you will rarely see prints as detailed as what you're going to in class, which is a good thing and also a bad thing. Bad thing because you're looking at these simple prints, simple little real world prints going, where's my GD&T? Where are my symbols? How deep's that hole supposed to be?
Yeah.
How many threads do I need? What class?
Right, we had a job order come through our shop from Hallmark. They have a card holder they won't weld it. And they put
A card what?
a card holder,
Oh,
and they literally put like a welding symbol arrow, and then at the tail end of it said weld. I was like, so you have no specifications on how big the weld, if it's stitched, continuous, hygienic,
Right, just to give you guys an idea of what some tolerancing will be like in a machining job. As long as it's not a job shop. Job shop will be, like, your prints will be just as detailed as what we're going over here. But you're also gonna be standing in front of a machine. Program will already be done for you. You push go, the machine runs, you're just there to pull stock and put stock back in. I mean, you work your way up from there, obviously, but that's where you start a lot of the time. If you get into a maintenance machinist job or tool maker or something like that at one of the factories, at Stanley, I don't know about Wireco or Duke or any of them, but for our exterior dimensions on the dissections, we don't put tolerances anywhere on any of our prints. Our rule of thumb is you've got 15 thousandths all the way around on a bolt hole, on a counterbore for a bolt. Exterior dimensions are within a half a thousandth. If it's not, put it back on the grinder and better touch light. Because a lot of the sections butt up against each other, and everything, all your cutouts are based on one corner of each part when they go through the wire EDM. And there may only be 20 thousandths of tolerance in location of that hole on your toolbox drawer. So if you've got 15 sections in a row and each one of them's out incrementally, just by a tiny little bit, it stacks up. And then you've got error from coil feeders and all that too that can, so everything for us is just size-wise, get it as close as you absolutely can. Everything else, precision's done in the wire room. Out on the floor, we do clearance holes, start holes for the wire machines, and make sure they're really good and square. So like it's rare to see a print that detailed. That is like, yes. That's one of those where I would probably grab my notebook, set it beside it, and kind of just draw bits and pieces of it as I work on it. Because I know that I'm not going to make that whole thing in one shot. There's going to be a couple setups there, if not more. So that's more along the lines of something that you'll see in class, and in this class, later on in the semester, actually. A little bit of slot, with some GD&T going on, which I get it, 2 coplanar surfaces. So this has to be parallel to this here, is all that. I'd have to refresh my memory on a little bit of this stuff because we also don't use GD&T. That's pretty self-explanatory. Perpendicularity, angle.
You said you don't use something?
GD&T. It's all these like symbols and call outs for this stuff right here. Like we'll use you're gonna see the dimensions for most places that you go, but unless you're working for a job shop or like Honeywell or NASA or something, I mean, I'm sure there's more to it, more than that, but I don't know who in town off the top of my head other than Ideal or maybe Duke or Gardner Denver that would use GD&T.
Pro Energy.
I'd say they probably do on some of their stuff.
Probably the turbines.
Mm-hmm. So this right here, for those of you that are just getting familiarized with prints, that 1/4 inch dimension right now, right there, is that talking about the length of that angle? Or is that talking about from this corner of the angle to the top of that part? Yep. I don't wanna dive too far into that right off the bat. Back into modern machining careers. That's something some of you guys may get into later, CAD CAM software. Having a computer do the programming for you. Some more stuff from my line of work. Wire machine, EDM. They'll actually go in like a dissection. Pretty normal size one for us would be the size of this book. And every perpendicularity and paralleleness call out, or every face on there is going to be parallel and perpendicular within a 1/2,000th if our guys actually checked their parts and didn't just go, close enough. Because we've got guys that do that, but even then, it's still within less than 1,000. With even on our 30-year-old wore out, beat to crap machines, I'm still getting stuff. If I try and pay close attention to what I'm doing, which normally when I'm working on a blade or something like that, I'm extra careful. I just turned one in last week that every face was within 2 10,000ths perpendicularity and parallels. And it was a 2.5 inch tall, inch thick, 11 3/4 inch long blade with a 3/4 inch radius cut out of it on one side. So when you're grinding stuff, it's easy when you're using a surface grinder. It's just about your set. Everything that you do in machining is going to come down to your setup and how careful you were with it.
Do you do any hand coding with the CNC classes?
Yes. You'll do. I mean, even some of them you'll write. You'll write in your notepad on your computer, and then save it to your USB and plug it in.
Did that in school?
And then you'll do some editing on the controllers out there as you go through and find crap that you missed, or oh crap, I almost plowed into the table. Well, like one of our guys in my 107 class, I think. It was my second CNC class. And it was I was partnering up with one of the better students that we had in the class. I mean, he was always, everything he did, he was on top of it. Apparently when we were going through our program, we somehow missed the fact that it was going to wrap it down to 100,000ths over our part with the Z-axis and move the table in the X and Y all at the same time. Like we missed one of our startup line codes, which you'll learn what that is eventually. But essentially, that code makes our X and Y move to home and keep our Z up out of the way, keep the head of the machine up out of the way. Then once the X and Y are home or to 0, the Z moves. It didn't do that, and that machine was the one that had the big ass 5th axis trunnion on it. And I mean, the spindle nose just boom. That's why there's a ginormous dent in the cover of that 5th axis, if you happen to see that.
Nice.
It wasn't me, it was my partner. It was Jake. All his fault. I was just standing there and
Did you help?
trying to not have to change drawers when it happened. It scared the crap out of me. Like, I was looking at something in the book and all of a sudden, BAM! Oh my God!
Did you help write the code?
I don't remember if that particular one I did or not. No, we hadn't put a program in it yet. We were, what the hell were we doing? I don't even remember. We were still getting set up though. But either way, you type in that startup line at the machine too, when you do certain things, and we still missed that code. So that's what I was talking about earlier, where you can set them up, set some fixturing up to do some batch parts on CNCs. I mean, he's literally taken what I'm sure started off looking something like that right there. Just like that, that bar bolted on there, and then his program comes through and I would imagine starts on one side and just comes through and does some contour here, back up around. I would picture it doing something like that, S-ing through, starting at one corner, coming off at the next. And then stepping the head down, coming back through again, tool down, coming back through again. And then finally a finish pass. But that's a really good way to make a lot of parts really fast, really efficiently. So I guess machining is relevant to becoming a mechanical designer, engineer, machine tool service technician. What? Those guys make buku money, by the way. Quality control technician, floor inspector, and industrial salesperson. Not so sure on that last one, but I guess it would make sense for it to be helpful.
Who makes the big money?
Huh?
Who was the one that you were saying makes?
Oh.
Sure.
Machine tool service techs. So they'll usually work within a region repairing different machine tools. Hey, talk about money. Money. Like you are basically, you set your own price. Especially if you're working on old stuff that people have a hard time finding parts for now.
Like the dailies at Maxion,
Like Rex.
cost a fortune to work on those. The dailies at Maxion.
Oh,
The daily presses at Maxion are like dinosaurs. They're so old, they said there's only like one other company that runs one in the nation.
wow. I wouldn't be surprised if a lot of the ones at Waterloo were like that by this point
They're
too.
real, the ones at Maxion are real original to the plate.
Right.
Because they're in the ground so far that good luck moving them.
Dynamite will move anything.
They have a basement. They have a basement underneath of them, so for the legs of the press, and then the legs are sitting on steel I-beams and concrete down like 20 feet. If we crash or die, you can feel it at the guard jack.
While you're in here, are we still good to get stock cut up and all that stuff before they get toolboxes?
Yeah, just go like normal. If you have the steel, it's gonna be.
Look, man, I don't know what normal is yet. I'm trying to figure that out as I go.
So Justin and I usually have them lay out class and we go over the stuff the first day, try to get all that crapola done, toolboxes checked out. These guys can't. Justin and I left you, there's 4 that we're sharing between all of our night classes. So you're welcome to use those 4. And they can even leave their stock they cut in your box for now, because you probably can't cut it all because our shipment hasn't come in yet. I think it'll come in tomorrow.
Okay.
So yeah, they can cut stuff up and go.